Hello all. I hope you've been enjoying the weather. I'm taping this on Thursday, April 23rd here, and it's been nice the last couple days. But hi, welcome. Volume of cones today. So a cone is defined as a three-dimensional figure whose base is a circle. It's similar to a pyramid because there's only one base. Remember, pyramids only have one base. Cones only have one base. Their base will always be a circle. Because it is a circle, then we would say that a cone is a non-polyhedron. It's not made up of polygons. The height of the cone, you guys, is going to go from the vertex to the center of the circle, of the base. Over here on our cone on the right, I'm going to trace over the height in red, even though it's already red, but here's the height of the cone. A new term, slant height. Now, had we done surface area, you would have used this a lot, but we didn't. We only did volume. The slant height will always be the slanted segment. You find slant heights in cones and pyramids, things that have one base. In a cone, the slant height will go from the vertex to a point on the edge of the circle. So we use H, the little h here, to denote height for all of our solids. We use a lowercase cursive L to denote slant height. So in your diagram here on the right in orange, this segment here would be the slant height. Now, which one should be longer, the height or the slant height? The slant height. Yippee! Good. Awesome. Reviewing circles here. Remember, the radius of a circle was going to go from the center of the circle to a point on the circle. I don't know why I wrote circle at that time. Remember, it's halfway across the circle. I'm going to highlight it here in black on your picture to the right. There's your radius. Now notice the height of the cone, the radius of the cone, and the slant height of the cone, they make this right triangle. So we will probably be using some Pythagorean Theorem, maybe some special right triangles within this section, so don't forget that. The base of a cone is a circle. Cool. To find the volume of a cone, remember, volume is the number of cubic units that fit inside of a shape. The volume of a cone is 1/3 big B times H, just like the pyramid, because remember, a cone and a pyramid are similar. They only have one base, so they're going to use the same volume formula. Big B, area of the base, H, height of the cone. 1/3 big B times H. So we're going to start here. Again, we try and keep this neat and organized as much we can for you guys. Try and show as much work as you can and also keep it neat and organized. We're going to find the volume of this cone. Over on the right, I have L, H, big B, and V. L, remember, stands for slant height. That is the slanted segment. I've labeled it on the diagram, and I've also typed it here. L equals 4. Easy peasy. The radius we know is 2. And in order to find the volume of a cone, 1/3 big B times H, I need to know the height of the cone. Height goes from the vertex to the center of the circle. It's always perpendicular. It's this red segment. Here, I'm going to use the Pythagorean Theorem to find the height. So leg squared plus leg squared equals hypotenuse squared. 4 and 16, I'm going to subtract 4 over, and I get h squared to equal 12. Undoing this square, we have to square root it. It doesn't say exact or round, so I'm going to leave it in exact form, which means I need to simplify the square root of 12 to 4 and 3. Square root of 4 is 2. We don't know what the square root of 3 is, so we are going to say that the height is 2 square root 3. This happens to be a 30, 60, 90 now, but we didn't know that for sure, so I used the Pythagorean Theorem. Big B then. Big B stands for the area of the base. The base this time, you guys, is a circle To find the area of a circle, it's pi r squared. The radius is 2. 2 squared is 4. We're going to leave this in exact form, so I'm going to leave it with 4 pi. To find the volume then, it's 1/3 big B times h. Multiplying this, 4 pi times 2, the number's all out front, give me 8 pi. And then I'm going to take my square root of 3 on there. Divided by 3, because it's a third. I can't reduce any of that. So in exact form, this would be 8 pi square root 3 all over 3 units cubed. Now if it did say to round, then when you put it in your calculator, you should get about 14.5. So make sure you know how to use your calculator with all those square roots and pies. Cool. Number 2 is on the next page. We're going to find the volume of this cone. It wouldn't be a bad idea to pause the video here and try it on your own. Alright, volume of a cone, same as a pyramid. 1/3 big B times h. L, the first blank is the slant height. That's the slanted segment. I'm highlighting it in orange. Our slant height is 10. The next one down, H, the height. I'm highlighting it in red. We do not know that yet. R, the radius here, halfway across, would be 6 since the diameter is 12. So we're going to need to use the Pythagorean Theorem once again to find the height. Leg squared plus leg squared equals hypotenuse squared. 36 and 100, subtract 36 over, h squared equals 64. Undo a square by square rooting it, and the height is equal to 8. Big B stands for the area of the base, and on a cone, the shape of the base is a circle. To find the area of a circle, it's pi r squared. The radius we had to use in the Pythagorean Theorem is 6, so this would be 36 pi for an area for the circle. Once you know your big B and your h, then to find the volume, you're just going to plug it in here to the formula that I wrote at the top. 1/3 36 pi times 8. Again, I'm going to keep this in exact form. 1/3 of 36 is 12, and then I can take 12 times 8, which is 96 pi centimeters cubed. Hopefully if you paused that and did it on your own, you got the same thing. Number 3, again, wouldn't be a bad idea to pause this here and try it on your own and see if you can do it correctly. L, the slant height, is the slanted segment in orange. I don't know what it is. But I do know here that the radius is 4. They tell me that the one angle is 60, so that means this last angle here has to be 30. I'm going to make this a little bigger so I can write into it. So I have this nice 30, 60, 90 triangle. Opposite of the 30, my radius is the short leg. Opposite of the 90, this would be my hypotenuse, the slant height. And opposite of the 60 is my long leg, which is the height. I'm going to go in red here. This is nice since I know the short leg. The hypotenuse in a 30, 60, 90 equals the short leg times 2. So that's going to be 8. In a 30, 60, 90, the long leg is the short leg times the square root of 3. So the height is going to be 4 square root 3. Filling in my answers on the right side here. Height, 4 square root 3. Slant height, 8. Now I got to find big B, which stands for the area of the base. Since the base is a circle, we're going to use pi r squared. So pi times 4 squared, which gives us 16 pi. To find the volume of a cone, 1/3 big B times h. You guys, the more you write the formulas down, the better you're going to remember them. 16 times 4 is 64 pi square root 3. Now 64 is not evenly divisible by 3, so I'm just going to write it as 64 pi square root 3 all over 3 feet cubed. That would be your volume for that cone. Last one, number 4. Find the volume of a cone with a radius 15 inches and a height of 20 to the nearest square inch. Here, when it says nearest, that means we're going to round. You can draw a picture if you want to. Sometimes you don't have to. It's totally up to you. If you do draw cones, all it really is an oval and then a triangle. There you go. It says here that the radius is 15, so I'm going to mark that in blue. And the height of my cone is 20, so from the vertex straight down in red, there's my height. So to find the volume of a cone, 1/3 big B times h. Big B stands for the area of the base, so pi times 15 squared, which would be 225 pi. H is the height, which they already told us is 20. So then to find the volume, we're going to take 1/3 225 pi times 20. And it says to round that to the nearest, not square inch, it should say cubic inch because it's volume. Cubic inch. So 225 pi times 20 divided by 3 gives me about 4,712 inches cubed. Cool! I'm glad you enjoyed cones. Have a good day.